Well, welcome everyone. So, ena iwi, ena mana, ena oa mahi, tēnā katoa katoa. E mihi ana ki a katoa, kei te mai ki te tātou tēnei kaupapa. E nā mihi nui ki Beth Webster, te kai kōrero o te rā. Tēnā koe. Ko Patrick Nolan, toko ingoa, nā mai, haere mai ki te tai ohanga. So welcome everyone to the latest Treasury Guest Lecture Series. I'm very much looking forward to the talk today. Today we'll be hearing from Beth Webster on the impact of digital innovation on new products, processes and competition. And Beth and I were talking before about how this couldn't be a more topical conversation. I literally this morning was using a sort of an enterprise version of ChatGPT that we've been trialing at Treasury, and I've got staff in my team using GitHub Copilot, and I'm just seeing as a manager the impact that the sort of artificial intelligence and some of this technological change is having on the productivity of my team and the ability of us to develop products and how we actually provide advice to ministers. So it's a very exciting topic. You know, for New Zealand, it's an especially important topic given the nature of our economy, a small distance economy, you know, where we tend to have relatively small firms, where we have our frontier firms tend to be disconnected from the global productivity frontier. So I think this is an incredibly important opportunity for New Zealand, and it's really important, I think, that we have we can access the best thinking and the best insights so that as a country, we can make the most of these opportunities. So given that, I'm absolutely thrilled to have Professor Beth Webster with us. She's the Director of the Centre for Transformative Innovation at Swinburne University of Technology. She's also Pro-Vice Chancellor for Research Impact and Policy. Beth's expertise centres on the economics of how knowledge is created and diffused throughout the economy. Her research interests cover several areas of applied economics, including innovation, intangible capital, intellectual property, firm performance, and public policy for the translation of science. And she's authored over 100 articles on the economics of innovation and firm performance. So I'll soon just hand over to Beth, who will present for about 45 minutes. We'll then have the remainder of the time for questions and for discussion. I invite you to use the Q&A function in Teams for moderating our discussion. So please post your questions there. So you'll see the Q&A button at the top. If you have any technical questions, then please use the standard chat function. So over to you, Beth, and once again, welcome to everyone.
Thank you very much, Patrick, for that introduction. And it's a great pleasure to be able to present to an audience, such a you know, well experienced and educated audience on these issues. And thank you to Patrick and Anna for inviting me to speak. What I'll do is I'll share the slides, so bear with me just in case this doesn't work. So that's, you can see that, Patrick, Anna?
Yes.
Great, terrific. So what I want to do is just take you through and talk to you about the impact of digital innovation on new products and processes, and also competition. It's a really broad topic, as I'll explain, and as you're probably aware. So it's sort of what I'm trying to try and do is just look at the systematic forces behind a lot of the digital innovations. So I'll start by giving you a few examples that I'm aware of a digital innovation, just to scope the area. So there's a business I know of. I'm in Melbourne, Australia, so it's just actually down the road here in Melbourne. And what it does is it's in the medtech area. It scans, it works with surgeons, and in this particular case, it's working with a surgeon in San Francisco. What they do is they scan the surgeon is actually replacing part of the skull with a new sort of synthetic skull. So it's possibly somebody who's had some sort of cancer or injury to their skull. The surgeon scans this person, the patient in the US. They send the image to Melbourne. In Melbourne, they create a digital design. They transmit that to the US, and they 3D print in the US and operate in the US. So it's a real two-way interaction between the surgeon and anatomics, that the medtech firm in Melbourne. And I believe that that happens within, within the time of the surgery. The second example of digital innovation is what you'd call dark factories. It's really an extension of the automation of manufacturing enterprises. But what's happened is that some factories now have so few workers on the shop floor that they don't even turn the lights on. One such example is the Dulux paint factory. This is an example. I don't think there is one in Melbourne, but this is an example. I don't think this is from Melbourne. It's probably in, somewhere else, but it shows you just how mechanised, automated manufacturing is becoming. So my expectation is that one day manufacturing might only employ maybe 1 or 2% of the workforce. It become just so capital intensive, in the same way that mining and agriculture only now employ a few percent around the developed world to produce all the mineral outputs we need and all the food we need. So too, my expectation is that manufacturing, as it becomes more and more efficient, will go down to those sorts of employment levels. And the third example is a much more prosaic and sort of maybe less high-tech example of digital innovation. And this is a fishmonger, and it's a business now called Saltwater Seafoods. So in the 1950s, the particular owner started off, they owned boats, they caught fish, they sold it in markets, the traditional way of harvesting and selling fish. In the 1980s, they started, they became a wholesale fishmonger. They set up in one of our local markets, and they used the fax and the phone to buy and sell off the boats. And then about 10 years ago, they started using email and WhatsApp, and they really scaled up, and they were taking fish off boats in the Pacific from New Zealand, the Maldives, or the Indian Ocean as well. They were grading the fish, sometimes by photo. They were quality checking them by photo. They were barcoding them, and then they were selling to very high-end restaurants in East Asia, particularly Japan. And they're now moving into satellite tracking. And this is operated out of an office, basically, in Melbourne. So that's basically what digital has done for that particular fishmonger. So they're three examples of really quite diverse things that are going on. Another interesting example, which I could have illustrated, is some of the computer scientists here at Swinburne in Melbourne have developed algorithms, and they've gone out to manufacturing firms that use a lot of energy, gas and electricity, and by optimizing the use of the energy, they've managed to reduce their energy usage by about 30 percentage points. So just no hardware involved, just applying algorithms and sensors to a factory floor. They've made this amazing saving in energy and carbon emissions. And I think they're looking at processed food and recycling of steel. So that's another example I could have presented, but it's a much more recent example. So some of the common digital technologies that people are talking about, well, computers, which began just after World War II, is really some of the first digital technologies. Artificial intelligence, big data, which has been around. I mean, a lot of what we call artificial intelligence would be highly familiar to all of you because you use regression analysis. It's just, a lot of it's just a souped up form of regression analysis. So machine learning algorithms just rely on millions and millions of regression analysis with feedback loops. Connectivity, drones, Internet of Things, which is basically when they put sensors in the ground or on particular pieces of equipment, 3D printing, algorithms, natural language processing, which is now coming to the fore with the GPT particular pieces of software. I think as of a few months ago, I went to a workshop on GPT systems, and apparently there's about 1,000 of these GPT software systems around. So ChatGPT is just, and Bard and Jenny are just some of the more famous ones, but there's actually up to 1,000. GPS, really, really important. That's a geographic positional systems. Has been around, I know, in the 1960s, the Americans were turning their satellites onto Earth to look at who was planting what crops around the world, so they could tell their farmers, look, you know, there's a lot of soya beans coming out of this country, maybe the price is going to go down, so don't plant soya beans. So GPS has been around a long time, but now obviously with Google Maps and all that tracking, it's become something that households use. So more and more things coming out, incredibly important. So what is digitisation? So I guess the best definition I've found is it's the conversion of text, pictures, or sound into a digital format that can be processed by a computer. So it can store information, automate physical processes, automate virtual processes too, with a lot of modelling, economic modelling that's going on, make calculations, and it's basically pattern recognition activities. One thing as economists, it can't, you know, we should be aware of, it can't do. It can't explain causation. It's really, a lot of it's correlation. And as we know, one of the big hallmarks of economics is identifying and separating out causation from correlation, or where there's a third party effect driving a particular relationship. So it does not get rid of that whole issue of, you know, what if I do something, what will be the outcome? It can only give you sort of correlations based on past patterns. So I think it's really valuable to put the digital wave of technological change into perspective. So people talk about there being 4 major long waves of technological change. The first one would be the steam engine. So in the late 17th century, that's about, I think it was about 1670, Savary created a very, very basic steam engine that was then refined by James Watt, and you probably know the history of what happened thereafter. So the next major wave was electricity, and that also had a very long run-up. There was a lot of people have known about electricity for a few hundred years before it was actually turned into something that was economically useful. Then came analog electronics, and then after World War II, we have the binary logic, which is the backbone of digital technologies. In between those, we have what might be called minor technological waves, interchangeable parts. That's the process whereby you can go and get a part from a hardware or a supplier, and it will fit and repair any machine for a particular specification. Interchangeable parts, by the way, was invented by the military, or back maybe I think the 18th or 19th century, I'm not exactly sure, but before they invented interchangeable parts, if a cannon needed a new cannonball, they would have to get a tradesperson to come up and make a ball to fit that particular cannon. And certainly if there was a breakage or they needed new parts for the cannon or the gun or whatever, they had to get a particular skilled tradesperson to fit it for that particular machine. So interchangeable parts was incredibly revolutionary. Factories was another minor technological wave, lean manufacturing, and there's a whole lot more that you're probably aware of also. On top of that, what's really important are what we call general purpose technologies. And Breton and Trachtenberg wrote about these 30 years ago. The thing about general purpose technologies is it's just not like another technology. They're pervasive and they're used in many industries and for many particular applications. So electricity would be a general purpose technology, steam engines are general purpose technology, and clearly digital technologies is general purpose. It's pervasive, it's used in many industries. It's dynamic, and there's continual improvement in the technology due to learning by using or learning by doing. The first prototypes are often a bit rough and ready, and they don't dominate the landscape. So when, say, steam engines came along, people were still using windmills and other forms of horse-drawn technologies. I think when steam engines were applied to ships, they were still continuing to improve sail technology in sailing ships. So there was quite a bit of overlap. When a new technology came along, the old technologies didn't suddenly die because they were still needed a lot of refinement to make them cost effective and make the quality improve and make them efficient. The third aspect of general purpose technologies is they have a lot of synergies and complementarities with other technologies. So just to give you a potted history of a lot of these general purpose technologies, the first, I guess, technologies that we have used in civilization would be just tools like the wheel, the lever, or the pulley. They magnified human muscle, but they did require human control. So it wasn't a set and forget. That set and forget aspect, which we would call first automatic control, goes back or is accredited to James Watt's steam engine. So prior steam engines, which was the Savary and the Newcomen steam engine, you needed quite a bit of human intervention to keep it going. What James Watt introduced was a feedback system, so you didn't need constant human attention. So that's as well as being efficient on other scales. Other significant inventions which lead up to this digital revolution is the Jacquard loom, which was patented in 1804, and that was where punch cards control a sequence of operations. And if you go to some countries today, like I've seen one in India, they still use those punch cards to put patterns into woven material. Charles Babbage, is credited with inventing the first computer. It was a mechanical computer because there wasn't electricity in the 1830s. And he saw that patterns of holes can represent an abstract idea. And Ada Lovelace did the first coding for his mechanical analytic engine. Charles Babbage's descendants actually immigrated to New Zealand, so there's probably some Charles Babbage descendants there today. It wasn't until, and then that really didn't take off. There was no electricity, there was no electronic systems in place, and certainly no digital formats. Then in the 1940s, the research started. Bell Labs is the research arm of the AT&T, which is a big American telephone monopoly. And the deal was with the American government that they would maintain AT&T's telephone monopoly if the research outputs from Bell Labs was not patented, or the patents were made available to the rest of the American economy. So that was a sort of a deal that I don't know if it was explicit, but it was a deal that was done in 1940s, 1950s. But the thing about Bell Labs is they had more. I mean, they had a number of Nobel Prize winners. They were obviously much more research intensive than most universities, but they invested First of all, they invented transistors, which is the on-off switch. That was 3 people, Bain, Brattain, and Shockley. They also Claude Shannon invented information theory, which was basically, it translated language and numbers into a binary format, 0, 1, and put them together and you get the modern computer. So that's just a potted history of technological change with a slant on the precursors to what we now call the general purpose technology of digital technologies. So, well, what does economic theory say about this? Unfortunately, a lot of economic theory treats technology as a black box. I think that's changing. But the traditional economic theory that certainly I was brought up in didn't especially different. A lot of it assumed technological change was exogenous to the economy to start with. So you didn't have any concept of investing in a technology to bring it to market to improve productivity. That was considered to be something that happened in businesses distinct from other economic forces. A lot of macroeconomic models don't differentiate general purpose technologies from just simple technologies like a potato peeler. And also, the general orthodox economic theory has a very narrow view of competition. It tends to think of competition as being just the concentration ratios or number of buyers and sellers in a market. I'm not sure why that's true. I believe that's because that probably goes right back to Adam Smith, who talked about when there's a small number of buyers and sellers, they will get together in coffee houses and talk about how to fix prices. But what Smith was getting at was collusion, not the numbers of buyers and sellers. So you can have vigorous competition with just 2 sellers or 2 buyers, and you can have collusion with a lot of buyers and sellers. So I think my personal view is that this view of competition's a bit, it's very much a rule of thumb, and it should be treated with caution, and you should really look at other measures of dynamic competition, because sometimes competition is really just a race to have better and cheaper products. But as we know, we value competition because it transforms markets, it changes supply chains, and it makes firms efficient. But it's also very important because it stimulates innovation. And I find it difficult often when people pose the question to me, well, does competition enhance innovation or not? And you know, there is a literature looking at whether the numbers of buyers and sellers, or competition as defined by numbers of buyers and sellers, enhances or hinders innovation. I find it difficult because innovation is the way businesses compete. It's the major way they compete in the long term. So sure, keeping prices down or reducing profit margins is a way to compete, but it only has a short run to run, in the sense that you can't reduce prices below costs and a little bit of a profit return. And the only way to keep competing in a long-term sense is to produce better products, find better markets, have better quality products, cheaper products, and find a way into global supply chains. So think of innovation as a way to compete rather than as two separate things, competition versus innovation. So how does this new wave of digital technologies compare with previous waves? So think of the steam engines or electricity. So both of those were normal products, normal intermediate or normal capital products. So you could exclude them. You know, if I buy a machine, it's mine. I can stop you from using it. If I supply electricity, I can determine who gets the electricity and who can't. I can therefore charge a price. So it's a normal product in that sense of being rivalrous and excludable. Digital technologies don't have that property. It's non-rivalrous. If I use Pythagoras' theorem, well, that's a technology. You can use it, doesn't diminish my ability to use it. If I invent an algorithm that saves my consumption of electricity in my business, you can possibly, with a little bit of small adaptation, use the same algorithm to do the same cost savings. Hard to exclude because just copying is very easy, and because the algorithms are hidden, they're often processes rather than products in themselves. It's really hard to detect. So you have it's a public good, basically. The marginal costs are close to zero. You have huge economies of scope. Digital technologies in combinations with supercomputers or physical processes of production reap huge economies. You have network externalities, which means that everyone has to be on the same network to be able to benefit. Like the telephone, you need to be on the same network for the whole network to use. Otherwise, you can't call each other. And interoperability is really important, and which means that you want to be able to transfer your telephone from one operator to another to ensure competition. It's very much a winner takes all race because of the marginal cost being zero. So we get these digital giants who can outcompete or outbuy other people in the digital space. And this creates a bit of a civil society issue, because it's not like in the days when many people can produce a steam engine, many people can produce a car, many people can produce other sorts of machinery or capital equipment. You have some economies of scale, but they're not sort of almost infinite or enormous. But here you have, we only need one Google with GPS, or one Microsoft producing software, Word software or Excel software. A slight exaggeration, there are other word processors, but they're usually for specialist niche markets like scientific word and some other sort of Python-based processors. Second difference between the current digital technology and previous waves is it affects the tertiary and quaternary sectors. So it's affecting medical areas, it's affecting accounting, it's affecting journalists, and now we possibly affecting economic forecasters. Previously, the technologies mainly affected manual labour. It replaced the hard yards of hoeing a field or producing a particular good, which were really taxing, awful jobs, or mechanical, boring jobs. So now it is affecting these other sort of jobs which we traditionally might have called high skilled. But that said, I suspect the sorts of a lot of the tasks within these high skilled jobs like radiologists is reproducing or replacing the more mechanical part of their job. So say take, for example, a radiologist reading an X-ray, the digital technology will read it and say, here's a bit of cancer here, or there's no cancer there. You will still need a radiologist to come along and look at it, but it has done quite a bit of the work for them. So I think they're the main differences that I can see between past big technological waves and the current digital technological wave. But there are some strong similarities too. And the first is that these things do take time to work through the economy. So the steam engine, I think, took nearly 70 years between having the steam engines were created to pump water out of coal mines because there was a real problem in England. The coal mines were filling up with water, which of course drowned people and stopped work. They invented the steam engine to pump water out. It took many years for people to apply that to movement, to apply it to trains, and then eventually they applied it to cars as well, or tractors. The electric motor, when it was introduced, as I said before, people are still using windmills and horse-drawn means of working factories, and it took many, many years to really come in and replace power in factories, partly because they had to reorganize the whole factory. In the past, they had these really long belts, so that maybe the windmill or the horse was driving, or a steam engine might have driven it. When you bought an electricity, it was small, it was compact, and you didn't need all that space for the big belts and the big cranks and what have you that they previously used. So the electric motor, I think, here I've got some figures showing that in 1900 it was under 5% of manufacturing horsepower in the US. It took another 30 years to reach 80% saturation. And again, these pictures are from America. At the same time as people were using these mechanical steam engine tractors, people were still using horses simultaneously. And the same is true for the digital technologies. Information theory, which was the binary logic, was developed in 1948 by Claude Shannon in Bell Labs. And we can say, looking, what are we now, 70 years later? And we're still seeing digital technologies being introduced, being refined and being applied in areas that they would never have thought of in the 1950s or 40s. There is this famous quote that I think the head of IBM said in the 1950s, that he could only ever see the use of they're being used for 3 computers in the world. So there was absolutely no, I knew somebody who worked as a gopher at MIT in the 1950s, and she said the computer there was the size of a 2-story building. And as you can imagine, in that sense, no one would have thought, we would have the power we have in a smartphone today. So basically, the full effect of digital technologies will take time. It's not just diffusion and knowing about it, but people got to think about how to reorganize their business and what skills they need and how to get the skills too. There's all sorts of lags there. Oh, sorry. I pressed the wrong button here. So one of the issues about these big technological waves is that the ultimate uses are very hard to predict. As I mentioned, the steam engine was devised to pump water. Here's the top picture is the picture of the steam engine pumping water. But it ended up revolutionising transport. And here's a first steam engine train down the bottom. Electricity was when it was sort of harvested and known about in the 18th century, was actually a party trick. It was a thing that people did it in parlours and people did this for magical shows, but it led to the whole redesign of factories and it changed workflows. And I know my grandmother always said that the greatest invention in her lifetime was the electric light bulb. It just changed the way people live and worked, just not relying on candle or gas lighting. And as I said before, when binary logic was invented, no one would have predicted that it would drive aeroplanes. So most aeroplanes these days have automatic pilot, and most of the trips are done automatically. We would never have thought it would read X-rays and replace a lot of the workforce of radiologists, replace mail, and coordinate supply chains. But the big thing about the current wave of technological change, like previous ones, is they eliminate the hard, boring, routine tasks. So why do we care as economists about this technological wave? Innovation just means change, and it just means change with a new idea. And I know the debate often in Australia is the governments in the past have talked about innovation so much, it's become a bit of a turn-off. So often when I go and talk to business groups, I talk about change, and that seems to be less threatening. But unless you change, the economy is going to stagnate because you're just going to be doing the same thing over and over again. And if all you do is invest using the same technologies as you have in the past, you're going to hit, well, diminishing returns certainly, but the returns to investing more and more in the same capital equipment are going to peter out and hit zero and eventually hit negative returns. So a very simple example is building a bridge across a river. The first bridge across a river has enormous returns to society and to the economy. The next bridge across a river has maybe positive returns, but not as much as the first bridge, and so on and so forth, until you get to a stage where just building more bridges across the same river is giving you zero economic benefit or zero social benefit, and it may cause negative benefits because you've got congestion. So the same principle applies to just investing using the same capital equipment or capital deepening or capital widening. It doesn't matter. If you don't have new, better, improved technologies to accompany that, you'll hit zero returns and eventually near negative returns. Another way to think of it is that the only source of long-run per capita economic growth is embodied in knowledge, and knowledge which includes skills, capabilities. Institutions are incredibly important. Institutions, by that I mean the rules of the game, how people organise and how they behave. Not just the formal regulations, but the informal ones are probably more important than the formal ones, because we all behave in certain ways without looking up the legal regulations the whole time. Alfred Whitehead, he was an early 20th century philosopher. He wasn't an economist, but he's one of my pin-up people. He had this wonderful quote, and he said, "Civilization advances by extending the number of operations we can perform without thinking, using symbols, formulas, and the price system." So he was going back, I guess, to Adam Smith's discovery that Adam Smith said, well, I look out my window and I see a highly ordered society. I see the farmer making enough wheat to give the the miller who mills the wheat to give it to the baker who bakes bread. And that's always enough bread for society or for people to buy. How do they know this? How does the farmer and the miller and the baker all know how much to produce? And Adam Smith's famous discovery, if you want to call it that, was it was the price signal, sending signals back to people along the supply chain or the value chain that there was too much or not enough of a certain good or commodity. So Alfred Whitehead, who obviously didn't know anything about digital technologies, recognised that the price system has got this amazing facility that we don't need somebody at the top telling all these people what to do. It's an automatic system. And I think were he alive today, he would apply the same principle to digital technologies. They're allowing us to extend the number of operations we can perform without thinking, whether it's GPS, sensors, Internet of Things, or predictive analysis. So how will digital technology affect productivity, or how does it? There are four major ways. It reduces unit costs, it substitutes labour for capital, reorganises the shop floor, it makes for faster information flows. So a lot of, I gave the example of where they'd use algorithms to improve the use of energy in a food manufacturing business here in Melbourne. It was a cheese manufacturing place. That was all about faster and optimizing information flows about when energy was needed, where and when to do maintenance and etc. Digital technologies can widen the market because it can make it easier for you to get into global value chains. Incredibly important for New Zealand and Australia, where sort of isolated from the major global value chains in the world, but partly because you know, the distance and that personal connection we don't easily have. It has to be quite an effort to make a personal relationship, but we can use digital technologies to enhance any personal relationships we have, to make things faster and to coordinate things faster, as you saw with saltwater foods, using picking up fish from the Pacific, grading it, pricing it and selling it into Japan, that's all done from Melbourne. Enables more flexible work patterns, as we saw during lockdown, so you've got better matching and access to skills. But it also enables us to do things that are not previously possible. So GPS, we can now, I know some of the things they're working on here in Australia is turning satellites to Earth to detect leakages of poisonous gas, to source minerals in the ground that they would otherwise need to deploy geologists on the ground to find, and to detect early detection of bushfires, to detect the whiff of smoke before it's visible by the eye. And also people are using GPS to measure carbon emissions. So that's some of the early stuff that I know we're doing here at Swinburne, but it's probably being done all around the world. Pattern recognition and AI, you're probably very aware of that. You know, put a photo into a computer and it will tell you who the person is. Pattern recognition, it's quite big. Sensors, control and feedback, which is really important in those dark factories. You know, if we're going to move to that great stage where only 2% of the workforce is needed in a manufacturing sector, we need a lot of sensors and controls and feedbacks. I know some of the mines in Western Australia, in remote areas of Western Australia, are now operated from a nice air-conditioned office in Perth, and that's due to sensors. And a lot of the trucks that they use to take the minerals from the mine site to the train station are controlled. They're driverless. They're controlled by people a long way away. And genomics. So the first human genome they mapped out or described, you know, I don't know, look, it took years and took millions of dollars, and it's now so incredibly cheap that it's a now commercial product. If you get what is it, 23 or ancestry.com, it's now becoming cheap. And in fact, I think young couples, before they decide to have a baby, can go and get tested to see if they both have the same unfortunate recessive gene that might affect their baby. So what's the evidence? Look, so there's surprisingly few studies on the overall effect of digital technology on productivity. There's a lot of very specific studies on particular industries or particular activities. There are many management case studies. but there's not a lot that look across the spectrum. Oops, I went down again. Sorry about that. Once I did a search and tried to find studies that are economy-wide, and this one here, it's only a correlation, but it gives you countries. Now I've highlighted Australia, but I can't see New Zealand. It'll probably be somewhere. Oh, New Zealand just beside Australia here where my cursor is. So this gives you the output per capita with how highly or pervasive digitisation is in the economy. So there is certainly a correlation, but we don't know whether that's because wealthy countries can afford to invest in digitisation or because digitisation increases GDP per capita, possibly a bit of both. One study that we have done here in Australia, and this is using our unit record enterprise data set, it includes 500,000 businesses over 20 years across Australia. You have a similar data set operated by NZ Stats New Zealand. And what we did here, a study I did with Alphonse Palancanray and Antonia Balaguer, is we estimated the rate of return to businesses that invested in R&D, that's called own R&D, that's the first column of data, and the effect that had R&D by technology group, the effect that had on other businesses in the same two-digit industry in the same state, so same geographic market roughly. And what we found is that while the rate of return to investing in all these different technologies was roughly the same by technology group, the external effects, externalities, or knowledge spillovers, as sometimes called, varied greatly between different technologies, and ICT and computer sciences had by far the greatest third-party effects. So that's the one piece of evidence we have that investing in digital technologies does have an effect on the economy. Now, this graph is just for Australia. You know, a lot of people beat their chests and say, oh no, the number of manufacturing's falling as a percentage of value add, which is true, it is falling. But in fact, the value add, since this graph goes from 1975 to about the present, the value add coming out of the manufacturing sector has actually been increasing continuously over this 50, 60 year period. And the labour force is going down a little bit. Certainly as a percentage of the economy, they're all going down, but manufacturing is still a real thing, and it's still increasing its output. It's still becoming more efficient and producing more things. And hopefully, my hope is it's about 6% of our value added today, might fall to 2% in the future. Here's a similar graph for New Zealand. Ignore the dots along the bottom. The blue line is manufacturing sales, and the dots along the top here is manufacturing employment in New Zealand. So what you can see is, okay, manufacturing as a percentage of the economy might be shrinking in New Zealand, but it is still increasing over time. So that goes from 1990 to the present. So should policy be concerned about what happens inside the firm? So this is always a big area of debate for economists. There are a lot of economists say, well, hands off, we should not be doing anything about what goes on inside the business other than, you know, providing, you know, a good macro environment and a good IP policies and a good regulatory environment. But there has been a shift in thinking that, in fact, if you leave innovation up to businesses to do, they will not necessarily do it in an optimal way. And this is a big area of debate, because you're looking at a lot of countries in the world, like the Asian tigers and America, where they do actually have innovation policies that actively affect their business, versus a lot of other countries where they're a bit more hands-off. So there's a management study by Bloom and Van Reenen and others who've looked at, the economist mantra is, if you've got competition, firms will automatically move to the production possibility frontier and adopt the best practice. And that we know that's obviously not happening, because we know a lot. If you do a DAE analysis, most firms are behind the frontier of best practice. They did a study to say, well, why aren't firms adopting best practice? Bearing in mind that the whole process of adopting best practice is an innovation. It's a new to the firm innovation, and it's a change that has benefits for the whole economy. And they've found 3 reasons why firms don't adopt the best practice. First of all, they're not aware of the best practice. Secondly, they've heard of these practices, but they don't believe they apply to them. And thirdly, the owner's time is constrained. They're reluctant to delegate. They don't know how to implement the change, or they don't know how to have the imprimatur from a board. If the CEO is not the owner, or doesn't have a lot of control over the board, they may know, they may want to do it, but they don't have the willingness of the board to agree to it. So especially in this digital area, what are some of the policies that we can use to enhance the widespread diffusion of digital technologies, both its creation and its diffusion? So complementary policies, people automatically think of patent and copyright, because patents and copyright are both limited monopolies that are granted to inventors. So there's the idea behind a patent in particular is to say, well, if you invest and create something, I will give you a 20-year monopoly to enable you to recoup your investments and stop other people copying it. So patents have been used in the last 200 years in most developed economies as a lever to encourage innovation. And there's quite a few studies that have shown that patents are associated with increased commercialisation. But that doesn't necessarily mean it's associated with the best economic outcome, because there is a static dead weight loss associated with patents that once developed, they do hinder diffusion. And there's, again, there's quite a few empirical studies showing they do hinder diffusion until the patent expires. But what you can also do is you can, without getting rid of the patent system entirely, you can invoke licenses of right, which basically means that, like the US with Bell Labs going back to the 1940s, they didn't invoke license of right, but they basically said, okay, this technology is so important, we are going to ask you to license it to other people at a reasonable price. So you're basically putting a little bit of a knife behind the back of businesses. They will still benefit, they'll still get royalties, but you're saying you can't monopolise it for 20 years. You can bring in standards of interoperability, and there are lots of standards or organisations in the world making sure we have the same interoperability between the internet, telephone systems, software. We certainly should be supporting those. Open networks are really important. FRAND pricing. FRAND stands for fair, reasonable, and non-discriminatory tariffs. It basically means that if we make your technology the standard for the whole industry or the whole world, you're getting a huge bonus, and therefore you must license it to everyone, no matter who they are. You have to license it to competitors, and the royalty has to be reasonable. You could have faster, more transparent IP systems. They're chronically low and slow and expensive. But the patent offices have been working behind the scenes to make them faster by sharing information between international offices, but that could be improved. So that's another way. And just as a note, I mentioned that patents have been acknowledged to hold back. They hold back the steam engine, they held back electricity, auto cars, radio. They held back the spread and diffusion and the development of and improvement of these particular discoveries. Other thing we can do is we can check the abuses of power. As I've said before, the digital giants are one outcome of digital technologies because they've got these amazing economies of scale. The marginal costs are close to zero. This can mean an abuse of power, especially in the public sphere, in civil society. You could have extreme salaries is another thing that causes a bit of social angst. You could have public ownership, you could have regulation, and you could do these deals between big business and the government. They're a little bit behind closed door deals, but previously they have worked in the US, particularly in the 1950s with all its antitrust activity. They got Bell Labs, IBM, DuPont to ensure that their discoveries of computers, nylon, synthetic materials, transistors was made more widely diffused. Copyright, I think the current international copyright laws are appalling. They give a monopoly right to somebody who's invented something for up to 70 years plus. It can go over 100 years easily. And there is no economic justification for that because the revenue, if you discount revenue streams beyond 20 years, they're tiny and they really don't affect the creative incentive. So everyone knows copyright needs a rethink, but it's held hostage to these amazingly effective rent seekers, basically. Enabling contestable markets is another thing they can do, like standard setting organisations. I'm running out of time, so I'll go a bit quickly. And enforcing monopoly platforms to accept competitor products, as I think with Microsoft was forced to accept Netscape back in the, I think, 1990s or 80s. Regulate footloose digital giants and bring in fair dealing legislation into your Copyright Act. Which basically means you can use copyright material for a lot of things like research, study, contracts, etc., and make it a bit more generous than what it currently is. Just two last points. The pathway for new to the world innovations, the pathway between an idea and getting it commercialized or getting it translated and used in society can often be really quite fraught. And a lot of governments have instituted or supported venture capitalists, or they've corporate venture capitalists or standalone venture capitalists to try and hasten this translation process, get across the valley of death. We had Ashish Arora out here in Australia talking to us about this particular process. And he basically believes, and he's got a theoretical model to argue the case, that this VC model is actually quite suited to software technologies, but it is not suited to many engineering, chemical, electrical, and physical based inventions. Basically, because the commercialization pathways are ex ante, very unclear and high risk. But they're ex ante, very unclear for software as well, but the technologies, the cost of the research is very low. So VC is suitable for software, but not for other sorts of commercialization of inventions, which may have software or digital technologies embedded in them. In fact, probably most of them have. So standalone software suited to the VC model, but not electrical and physical stuff. But his evidence, and this is for the US, shows that if you want to improve the commercialization for other technologies, you need to improve the commercial pathways. And that is not just the knowledge of how to commercialise, but the relationships along the way. So he talks about how it's the output of PhDs, especially PhDs who've done time in industry and have relationships both in academia and industry, matter a lot for commercialisation. A lot of successful inventions are commercialised because the researcher who invented it, who may be in a research institute or university, is an ex-colleague or an ex-student or an ex-supervisor of somebody in industry, and those relationships matter. And they matter because commercialization's highly opaque. It's hard to know from the outside whether something works or how good it is, how robust it is. It's highly uncertain. And there's a lot of room for people to take advantage of it and act in an opportunistic way. So trust is really, really important in commercializing invention, both with and without digital technologies involved. Other things governments can do is they can have business technological brokering services. I know you have quite a few of those centred around the University of Auckland in New Zealand. Governments can pledge to buy innovative products, and the departments of defence around the world have been doing that for hundreds of years. And it's a very important way that high-risk technologies like computers, satellites, GPS get developed and then have dual-use commercial application. So governments can extend that or extend the range of products. And basically, governments can help by designing systems to effectively manage this transfer process of new ideas. This picture here is a picture of one of the R&D corporations in Australia. It's the Grains Corporation, whereby scientists link up with farmers to solve particular problems they may have in the field. So that's another thing that can be done. And I believe Callaghan Innovation work in this area, but you would know more about it than I do. So that's all from me. Thank you very much. I'll stop sharing.
Awesome. Oh, well, thank you very much, Beth. That was a fantastic presentation. You started off by talking about the 4 major long waves of technological change. Then we discussed a bit how the digital technologies compare with previous waves. In particular, some of the sort of the non-rival in consumption and hard to exclude. I think that's something we'll have to come back to, because you can see a lot of the policy implications flow out of those characteristics. You know, marginal costs approaching zero, some of the winner-takes-all dynamics, but also the fact that it's not just impacting on manual labour. So, you know, you also mentioned economic forecasters, which is quite a shock. But there we go. For these folk at Treasury, but there we are. But then also you talked about how the full effects will take time. Talked a bit about the process of diffusion and the restructuring lags, and then, but also the importance of change, that unless we change, the economy will stagnate. So, you know, it was a really good presentation. We've got some questions in already. I'm going to exploit my post as chair and sort of also ask one, and I'm going to link it. So Lana has asked about largely around what is key in lifting the capabilities of change actors, firm owners and executives, and has also asked about the issues around lifting management capabilities of business executives. So I think that's an excellent place to start. Could I also ask you about the other side of the that sort of coin in a way, and that's how government should be designing support schemes. And I don't, you know, not just sort of at an individual level. I think, you know, sort of overall as a system as a whole, if there's some sort of key things that are done right, or you know, mistakes that people have made. So if we start with those, and then we'll go from there.
Okay, management. So it's really hard to get good empirical information on, does, you know, training a manager or putting them through a masterclass have an effect? There have been a few studies, like Bloom and Van Reenen did a non-natural experiment. They did an actual experiment in India where they gave, you know, randomly had a group of businesses. They randomly allocated them to control and treatment. And they looked at what happened to the treatment group. So the treatment group got managerial training on how to save wastage, improve their workflows and what have you. And they did get a positive effect. I think that study's about 10 years old. We have a cooperative research centre program here in Australia, and one of them, a manufacturing one, recently had a module whereby they take businesses in for a workshop. It's free. It's targeted at SMEs. The workshop is all about benchmarking and working out where you stand, what you need to do, where your weaknesses are, where your strengths are. The actual workshop, I think, comes from the Fraunhofer in Germany, so it's an adaptation of that. And a colleague here did a study. It's not a experiment, and it doesn't have a control group, but they put it into our business database. They did propensity score matching. They created a synthetic control group, and yes, they found that businesses did have higher sales after they went through this program. There was about 300 or 400 businesses in the program, but we can't control perfectly for endogeneity. We don't know whether the businesses that did the program were those that were the most managerially adept, keen, willing to change, and what have you. We've done also quite a bit of work evaluating our export promotion programs, like trade missions or getting a grant to do marketing in another country. They all come up pretty well as having an impact on export sales. So we know, again, we can't control perfectly for the fact that, okay, the more gung-ho, the better businesses do the programs. But one thing I'll say is all these government support programs are not welfare. We don't want to help the firms that are about to die. We want to help the gung-ho ones. We want to give them an extra lift. So it's all about improving the economy. So we don't worry so much that we've got a selection effect. In terms of evaluation, we do, because we can't control for it. But we know that the selection effect would have to be huge to get rid of our significant effect. So we do take account of that to some extent. What we don't know, two things. Does the effect of giving management workshops or classes to business have a long-lasting effect? Because our data only goes to 3, 4, 5, 6, 7 years after they've done it. And secondly, we don't know what effect it has on the cluster in their particular niche, because government programs aren't about just helping one firm. We can't afford to do that. It would go broke. It's about raising all boats at that little industry cluster. So it's all about externalities, the third-party effects, and that's something we don't know. So we would like to do more empirical work on that, but I don't know. I know hardly anyone in the world, and we've looked, who really investigates empirically those third-party effects. So if anyone wanted to do that on your data, that would be fantastic. The second part of your question, design of support schemes that the government can do. I really like, so one thing Ashish said, and he's talking about America, he said, one of the reasons the life sciences in America do so well, and this is Silicon Valley and that cluster around Boston, is because there is a well-worn path to commercialization. So if you're working on a blood product and you're working maybe a way to mitigate some disease, whether it's a common disease or an orphan disease, ex ante, right from the get-go, you know which businesses are going to be able to develop it and which businesses are going to be able to market it and sell it to doctors, hospitals, or consumers. Right? It's a well-worn path. So right from the decision to invest in that discovery process or that research process, you know who to bring into the tent. You know who to ask to co-fund it. You know what the regulatory hurdles are, what you need to think to jump, and so it just makes that whole commercialization path much smoother and clearer. I suspect Fonterra is in that space too. You know, they've got such a well-known path, including both selling commercially to New Zealand and to China, their major customer, that when they put oligosaccharides into milk, they know who they're hitting, how to advertise it in China, where the consumer market is, and what their competitors from the Netherlands are doing and how they're going to beat them, right? So this has sort of occurred naturally in some, and I suspect this is the case for minerals in Australia too. They know right from the start, you know, what the plan is. This is not true for a lot of other industries. When they discover things, they don't know who's going to use it and how valuable it's going to be, because they can't. It's the unpredictability of what they're doing research in is such that sometimes they'll invent things and they can't use it. They have to try and sell it to another company, which, you know, that market is fraught. That market for technology is, there's a lot can go wrong. So one thing the governments can do is, it's like that R&D corporation model. They can, in areas where you think your economy, the New Zealand economy, this could be a new champion industry. This could be another dairy industry, you know, in another area. They could talk to the major players in the area and talk about how they can broker and make that pathway smooth, whether it's exports, regulations, the technology, the scale up, whether it's bringing in foreign direct investors who will bring in complementary technologies, and it's bringing in the relevant universities who you know have a strength in that area. And that's what a lot of the Asian tigers did, including Japan, and in, you know, when they went from, you know, they did that heavy ramp up last century. They and it didn't work in every industry, it doesn't always work, but the government got together a whole lot of players in the area and said, okay, you know, what's our end goal? What do we got to do? And the industry associations should be coming up to the fore too, stepping up. It's not just, you know, going to the government for grants is not a good model. The government runs out, it's not a sustainable model. Government runs out of money. There's a change of government. They get rid of the grant program. It's always too small. The costs of applying for the grant are too great. So it's working out those sustainable models to support the industry. And a lot of it would be institutions and regulations and just bringing the right people together. The National Science Foundation in America, who give out research grants in universities, they curate a lot of their research grants. They don't just do an open call for, you know, everyone's crazy idea. They will say, look, this is a problem. You know, it's a more of a mission, have a bit of a mission-based aspect to it. This is a problem we need to solve. Who's the best person in the economy? Let's bring them in and work on it.
Cool, great. So we've got a question that nicely segues from that, from Natalia, which segues from the discussion on the decision to invest in the discovery process. So she's asked, she said, thank you, Beth, for the fascinating talk. Are there risks to adapting innovations too quickly, unknowingly losing knowledge or productivity along the way? So, and then she gives some examples. So, so as you said, the ultimate use cases of these technologies are often hard to predict. So it is a risky activity to innovate and to make change. So can you go too fast?
Yes, you can. And I think there is a lot of history of inventions that were ahead of their time, like Charles Babbage's analytic machine. You know, it didn't have electricity, it didn't have a lot of data. It was a great idea, but it got shelved. You know, there was a automatic washing machine invented in the 19th century, but no one had electricity and running water, so that got shelved too. So there's a lot of, I think you're absolutely right. And there's a book by Josh Lerner called The Fast Second, about how the first person to invent something was too far ahead. They didn't have the complementary assets in place or the complementary things that would make it really work. And yeah, they floundered, they ran out of money, they didn't bring in the relevant partners. So I think we've done surveys of the markets for technology, and what we find here is that when a business invents something and it's not part of their core business, they do seek to license it or sell it somewhere else. And I think that's probably a good model. You probably need a good IP system for that. And you need sometimes selling things for equity is better than selling it for cash. Because if you say I've invented something, I can't use it, it's a great idea. Patrick, I can see you need it. I might sell it to you for, 5% of your shares or, equity in your company. And that gives me that means our interests are aligned. I want to see it succeed in your company. I'm not going to try and take too much out of your company that you fail. I'm here to help you with any knowledge you need to get that thing working. Equity really there's no cash out the door, so it's not going to make you broke in the first instance. You're not losing control. You're only giving me 5% equity or, whatever. So there are models of transferring technology that make more sense than haggling with lawyers for a year over a contract with royalties. You fight for a year to get 20% of nothing. And then when you've got royalties, you're setting up a situation where what I get, you lose, sort of thing. We're not both going on the same page as well. So again, the research we've done on markets for technology show if you're haggling over royalties in the contract when you're trying to trade technology, they're more likely to fall over if compared with equity type deals. So yes, I absolutely agree. And I think being aware of what else is going on in the world, knowing your technology landscape I think it's very important. And digital technologies can really help there. I wouldn't trust ChatGPT because it hallucinates too much and comes back with things that are just not true. But there are people who've built databases based on scientific publications, patenting, and just new products. They've scraped new products off the web. So if I invent something to improve the efficiency of a carburetor or something like electric motor, and I can put in the technical terms for that into these data sets, you should be able to see who else in the world is working in that space, who I need to talk to work out, look, have I got something? Have they tried it? Has it failed? Should I be talking to them to sell it to them, or should they be coming on board with me in a joint venture, or or should I just give up?
Great. We've got a question from Jeff, which also makes me think about this issue about risk. So he said, oh, hi, Jeff, by the way. But Jeff has said, great talk, Beth. Thank you. Is there a catch-22 with firms investing in innovation technology and paying higher wages? You need the former for the latter, but low wages incentivize sticking with labour-intensive methods. It's also, I guess, innovation is also risky. And if you're used to just having a sort of a labour based approach to production, it's maybe easier to stick with that as well. So I don't know if you had anything to add on that, or
only the equity deals are often common amongst startups I know, whereby they're paid a low wage, they're highly skilled, they could get a job anywhere, but you give them shares or some sort of bonus related to the success of the firm. So and it is a real problem. And I know people talk to me about the tax treatments. They tax them at the wrong time. They tax them before they're realised, and the tax treatment needs to improve. I don't know what it's like in New Zealand, but that is one model where you're sharing the risk with these highly skilled employees. Because after all, without them, invention is a labour-intensive process. You're not going to succeed. So that's the only thing I can think of. But yeah.
And what about the kind of the rise of the superstar firm? Because I guess there's a broader question around sort of inequality, and that if you have this winner takes all dimension and you get the superstar firms rising, and then as a result, wage rates are going up in those firms, you can see a widening of the distribution. So is that something that you find concerning, or?
I do. I saw what the big film, book, Disneyland type enterprises do to copyright, and there is no economic argument for having copyright as strong as it is in terms of the length of the monopoly right. The length of the term copyright at the moment is, I'm not sure about New Zealand, but in America, and America forced it on Australia too, it's 70 years post-mortem. So after the death of the author, it's another 70 years. If it's something, excuse me, it's invented by a group of people or a corporation, it's 125 years, like a film. Now that, me getting $1 in 125 years is not going to affect my incentive to make a film. You know, okay, I'm not going to be alive to start with, but even if it's 30 years, I don't think it's going to affect my incentive to make a film. But in 30 years' time, I'll be deliriously happy if it's a blockbuster and I get lots of money. So there's no economic argument for having that as an inducement to create films or books or you know, anything in that creative area. And the fact that the law is strong there and getting stronger is due to these big media giants in mainly in America going to Congress, forcing Congress to adopt these standards, and then through free trade agreements forcing other countries in the world to adopt them. So, and that can play out now in digital technologies, although Google's opposing these media giants because they're on the opposite side. So maybe if you have two giants fighting, you get a good result. But I think it's a concern for civil society. I know the whole area of tax avoidance, tax havens has been a big issue. You know, lots of companies have been paying zero tax, and that's because they've been stopping international laws mandating a minimum company tax rate, which they've now, I think they're bringing in from next year or soon, but that has taken decades to resolve. And I believe that was because of the power of those large corporations, and this is a corporation in every country in the developed world, have been using those tax havens. So taking decades to get that resolved, and the minimum international corporate tax rate is just 15%. It's still incredibly low, but it's better than zero, but it's not maybe where we'd want to go. So I don't particularly have a solution to that other than civil society being aware of what's been going on, and that because they do things and it's so opaque, it's hard to see, you know. And the current one at the moment is disinformation on the social media and other places, because it's so hard to see. It's so hard to unpick a lot of what's going on. I think maybe a more educated, more active society is probably called for, or a more responsive government, but they respond to, you know, lobbying and the ballot box. So it's a hard one, but it's a concern. Yeah.
Well, we're right at time. But
Yeah.
I just one last question, a sort of an overall reflection. Just looking at some, funnily enough, some Lightcast data, and looking at so this is job vacancy data, and they just look through and to see you know, what words are mentioned, and so they were looking for you know, if vacancies for people with programming skills, and, you know, sort of the degree to which digital technologies are being picked up in applications. And it was really interesting to see the rise in Australia, and in New Zealand it's been relatively flat. So I guess I'm just be interested to know the sort of the scene over there in terms of digitalisation. Has there been you know, has there been a lot of growth in the interest in this area in Australia, and how do you feel sort of looking forward?
I think there is. I'm not that, you know the data more than me, so you're ahead of me in terms of rise of it. In the university sector, we're actively talking about introducing digital science modules or units into courses. So one thing I want to do, I think Monash and Melbourne universities are already doing it. They're introducing data science or Python, coding in Python, basically, into their economics degrees. So the economics graduate of today, they will need to certainly know about what it can and can't do by the time they're 50. And if they can't, you know, it's going to be a real problem. They don't need to be expert coders, but I understand you don't need to be an expert to actually use it quite effectively. And I know I've seen articles about accountants saying, you know, you are no longer bookkeepers. You need to be able to use digital technologies to be able to advise firms what to do and to be able to pull in information and show them how to pull in information to run their businesses better. So business strategy is going to become, I think, more important in the accounting area. We've got Xero software, which takes stuff from your bank account, pulls it into journals for accountancy. So a lot of the bookkeeping part of that accountancy's automated already. So in terms of training today's accountants and economists, I think we need to have digital subjects built into the degree. And certainly the demand I see coming from students shows that's the case, that they're interested in that. In terms of the labour market, I don't know. When we work with data scientists here at Swinburne in our economics research unit, and we go and we raid the astronomy group for their best PhD graduates, and they make fantastic data scientists. So
good. Awesome. Oh, well, thank you, Beth. Unfortunately, we actually have run out of time, so I will need to bring things to a close. So thank you very much, Beth, for taking the time to share your insights and experience with us today. And thank you, everyone online, for joining us. Our next seminar will take place next week on Monday the 19th, and we'll have Dr. Serge Peltez from MIT, and the session will focus on the role of hydrogen in low-carbon energy transition. And it will be a hybrid event, so you're welcome to join us here at One the Terrace, and you can register via the Treasury website. So let me now close the seminar and say farewell with a whakatū, which says that discussion, learning and understanding and knowledge underpin the well-being of all people. Mā te koreo ko mohio, mā te mohio ka marama, mā te marama ka matua, mā te matua ka ora te iwi, haui hui e taiki e. Great, so thank you again to Beth and to everyone for participating today. Mā te wā. Thank you.